Hello folks, this video covers page 1 of your chapter 8 study guide, preparing you for your test on vectors. So number 1, every vector has magnitude and direction. What is magnitude? What is direction? Well, magnitude I think is the one that's a little bit more obvious of the two. Magnitude is simply length. Magnitude is length. Direction is the one that some people kind of forget what it actually means. Obviously, we have like north, south, east, and west, and all of the variations among those literal directions. But in order to actually find it, direction is the angle, which we usually use theta for that variable until we find it. It's the angle between the vector and the positive x-axis. So direction is the angle between the vector and the positive x-axis. Number 2, when you add two or more vectors together, the answer is called the resultant vector. The resultant vector. Number 3, use the parallelogram method to figure on the figure below to determine where the resultant vector would be located. So this is literally the first thing we talked about in this chapter. Geometrically speaking, if I wanted to add these two vectors together, so accounting for their length and the direction of each of them, we had the tip to tail triangle method, but the parallelogram method is the one we've used a little bit more frequently. So basically the idea is for you to fill in the other two sides so that it would make a parallelogram with the two given vectors. And then the resultant vector would be the vector that starts where the two other vectors met tail to tail, and it would go across your shape like this. So the resultant vector would be that red vector there. Now, I didn't ask you, specific numbers to measure the angles or the altitude or the magnitude or anything, but that's just geometrically speaking. Number 4, using this figure, name the following. Name the horizontal component of vector S. Well, horizontal is going to be literally the vector that is horizontal. To name a vector, the direction of the arrow is important. This vector starts at H and goes to M, so we have to put those letters in order. Vector HM. And then the vertical component, it starts at M and goes up to C, so that one will be vector MC. If they had letters out here to the side like this, vector A and vector B, then you could use those. But if letters like that are not given, then you have to use the letters of the points where those vectors begin and end. Numbers 5 through 7. I'm asking you to write the ordered pair that represents vector AB and then to find the magnitude of that vector in simplest radical form. So this one has two parts. Part 1, in order to write the ordered pair, ordered pairs are found when you do x2 minus x1, y2 minus y1. And of course, that's in 2 dimensions. In 3 dimensions, you're just going to do z2 minus z1. So for number 5, that's going to be, if we take our x's, that'll, again, x2's, you'll always take the second coordinate and subtract from it your first coordinate. Direction matters. So this would be 5 minus 4. And then the y's will be negative 5 minus negative 2. So when we simplify that, we get vector AB is going to be the components are going to be 1 and negative 3. So there's the first part of your answer. The second part is to find the magnitude. Well, once you find the vector components, 1 and negative 3, in order to find the magnitude, you're going to take the square root of those components squared. So 1 squared plus negative 3 squared, which when you do that, that's going to be the square root of 1 plus 9, which is just the square root of 10, which cannot be reduced at all. So magnitude, remember we use absolute value for magnitude, is going to be the square root of 10. And there's the second part of your answer. We're going to do the same things for 6 and 7, except these are just in 3-dimensional space. So we're going to have the z term as well. So to find the components, we're going to subtract -3 minus -2. Be careful with those double negatives. 5 minus 4, 2 minus 7. So then that's going to give us vector AB. Oh, not magnitude yet. Vector AB is going to equal -3 minus -2. It's going to change to a plus a positive, so it's going to be -1. 5 minus 4 is 1. 2 minus 7 is -5. Magnitude, we're going to take these components, square them, and then take their square root. So the square root of -1 squared, -1 squared, plus 1 squared, plus -5 squared. Be careful, as I'm looking at that, that almost kind of looks like 57, but that's just my symbol, so be careful on a test that you are pay very close attention to detail in reading your numbers. When we add these together, it's going to be 1 plus 1 plus 25, which is going to be the square root of 27. Now, simplest radical form means we need to find if there's a square factor of 27, which there is, the square root of 9 times the square root of 3. So the magnitude of vector AB will be 3 square roots of 3 when all is said and done and we simplify it. Number 7, find the components by subtracting 1 minus 0, 4 minus 6, -3 minus 3. So that's going to reduce or simplify. So 1 minus 0 is 1. 4 minus 6 is -2. -3 minus 3 is -6. Be careful there. I could see some of you accidentally canceling that out to be 0 if you're not careful. So that's vector AB. And then to find the magnitude, again, we're going to square the components and then take their square root. So that's going to be the square root of 1 squared plus -2 squared plus -6 squared. So that'll be 1 plus 4 plus 36, which will be the square root of 41. There are no square factors. In fact, there are no factors. 41 is a square number. So then we'll say the absolute value, well, technically the magnitude is how we would describe that, would be the square root of 41. Numbers 8 through 11 use these vectors that are described here. So it says find an ordered pair to represent vector u in each equation if, and then it tells us kind of what to do. So again, this is really easy cheesy kind of stuff. You just have to be really, really careful with your operations, particularly anytime subtraction is involved or negative numbers are involved. So for this first one, when we do w minus 2v, well, vector w I'm going to leave alone. That's -3, 5. This minus 2v, you can do two things. You can distribute -2 to v, or you can distribute the 2, which is what I'm going to do, and keep my minus sign. So I'm just going to be distributing 2 to vector v. So 2 times 2 is 4. 2 times -1 is -2. And then I'm going to distribute this minus sign to each of them. So then vector u will equal -3 minus 4 is -7. And then 5 minus -2 changes to plus a positive, which is +7. Number 9, vector r minus vector q minus vector s. So let me write out what those look like. R is 2, -4, -7. Minus q is 5, 0, 8. Minus s is -5, 1, 11. So again, here, the math is really easy. Just make sure you're paying attention to which numbers are which. So if I do all of the x's, that's going to be 2 minus, remember you have to distribute this negative here, 2 minus 5 minus -5. Okay, so 2 minus, the -5 and the minus -5, this changes to a +5. Those two guys end up canceling, and you end up with 2. Do the y terms, that'll be -4 minus 0, so pretty much that goes away. There's no middle number to do. So that'll be -4 minus 1, which is going to give us -5. And then to get the z's, we have -7 minus 8, so that's going to be -15, minus 11 will give us -26. So just take that one number by number. 10's a little bit easier. Again, it's only back to two vectors that are in two-dimensional space. So 13 times vector v, that's going to be 13 times 2 is 26. 13 times -1 is -13. Plus 15 times the vector w. 15 times -3 is -45. And 15 times 5 is 75. Okay, then add these numbers together, x with x, y with y, and we get vector u. -26 minus 45 is -19. -13 plus 75 is 62. So vector u is -19, 62. Last one, vector s plus 4 times vector q minus 3 times vector r. So let me write what these are. Vector s is -5, 1, 11. Plus, I'm going to distribute this 4 to vector q. So 4 times 5 is 20. 4 times 0 is still 0. I could see some of you making that mistake there and putting a 4 because you added instead of multiplied. But remember, you're multiplying. Anything times 0 is 0. 4 times 8 is 32. Minus, I'm going to distribute just the 3 to vector r. So 3 times 2 is 6, 3 times -4 is -12, and 3 times -7 is -21. And then again, go x with x, or x's with x's, y's with y's, etc. So -5 plus 2 is plus 20. Ooh, I almost made a big mistake there. Is 15, and then 15 minus 6 is 9. The y's, 1 plus 0 doesn't change anything, so it'll just be 1 minus -12 changes to plus a positive 12, which is going to be 13. Oh, and I forgot my vector notation. Okay, so 9 for the x, 13 for the y. And then for the z, that's going to be 11 plus 32 minus -21, which is going to change to plus a positive, which will be 64. Numbers 12, 13, and 14 ask you to find the magnitude of each vector below in simplest radical form, and then write each vector as the sum of unit vectors. So it's a two-part problem. The first part is just to find the magnitude. Now, this is not like 5, 6, and 7 where you had to do all the work first to find the magnitude. If I'm already giving you your vector in vector form and with the component form here, then to find the magnitude, you're just taking the square root of these components squared. So it's going to be the square root of 4 squared plus -5 squared, which is going to be the square root of 41. So that's the first part. Again, 41 is a prime number. You can't simplify it at all. The magnitude part's easy. As far as the sum of unit vectors, you need to remember that just, the unit circle has a radius of 1. Unit vectors have magnitudes of 1, and they are pointing in the direction of their axis. Okay, so their direction is it goes along with their axis. So like the x-axis unit vector is going to be vector I. The y-axis unit vector is vector j, and the z-axis unit vector is vector k. So when I ask you to write this as a sum of unit vectors, there are no commas. You are literally describing this vector as if you were to multiply unit vectors by a scalar and then add them together. So for number 12, I have only an x and a y. So my x-axis unit vector is I. So this one's going to be 4 times vector I minus 5 times vector j. That is how you write it as a sum of unit vectors. Number 13, let's find magnitude first. We're taking the square root of 0 squared, which is obsolete. We don't even really need to write it. plus negative 3 squared plus 6 squared. So that's going to be the square root of 9 plus 36, which is the square root of 45, which there is a square number that's a factor of 45, which is 9, and it goes into 45 5 times. So when you simplify that, that's going to be 3 square roots of 5 for the magnitude. As far as the unit vectors go for this one, again, these components are the coefficients, x, y, and z. Okay, these are the scalars that you're multiplying those unit vectors by. So this one's going to be 0 times vector I minus 3 times vector j plus 6 times vector k. Now, 0 times anything is just 0. So as your final answer, we'd have 3 times vector j, not vector 3j, 3 times vector j, there we go, plus 6 times vector k as your final answer there. For number 14, if I try to find the magnitude, same thing as number 13, take the square root of the 3 components squared, negative 1 squared plus 7 squared plus negative 2 squared. So it's going to equal 1 plus 49 plus 4 is going to be 54. And again, 9 is a factor of 54 6 times. So then your magnitude is going to be 3 square roots of 6. As far as the unit vectors go, again, we have an x and a y and a z. So this is going to be negative 1 times vector I plus 7 times vector j minus 2 times vector k. Just like with coefficients and variables, we don't need to write coefficients of 1. So your final answer, and I'll say simplest form, will just be negative vector I plus 7 times vector j minus 2 times vector k. For number 15, first of all, I apologize. I didn't really give you a ton of room to work with here. So for that, I am sorry. Because there's a little bit more work that has to be done in terms of the little space that I gave you. So if you're just working on this for the first time, I suggest writing small. I also suggest drawing a picture that represents this scenario. It says Nancy and Harry are lifting a stone statue, moving it to a new location in their garden. Nancy is pushing the statue with a force of 120 newtons at a 60-degree angle with the horizontal. Well, if you haven't learned by now, pretty much all of these scenarios can be drawn on a coordinate plane. And the horizontal obviously is talking about the x-axis. And if they ever use a point vertical, clearly it's talking about the y-axis. Okay, so let's draw that vector, what it looks like. Nancy is pushing the statue. Whatever your object is, that's typically also going to be the origin. Okay, so let's pretend the statue is at the origin. She's pushing on that at a 60-degree angle with a force of 120 newtons. Let me make that a little bit shorter. Okay, your force acts as your magnitude, so label that with 120. And then that angle is going to be 60 degrees. Okay, that's Nancy's force. It says Harry is pulling that stone statue, or is pulling the statue, with the force of 180 newtons at a 40-degree angle with the horizontal. Now, I'm going to be honest with you. When I did this question the first time, I drew it as if Harry was on this side in quadrant 2 pulling on the statue. That ended up giving me what the book said was a wrong answer, the resource I was using. And so I did it this way, the other way that I'm about to draw, and it gave me the right answer. I will say on your test, I'm not going to give you a situation that you're going to have to kind of guess, this real life scenario where you have to guess which side it is. In fact, I'm going to try to keep drawing to a minimum because I understand how challenging that can be if you put one number in the wrong spots. Okay, so Harry is the 40-degree angle on this side he's pulling, and his force is 180 newtons. And again, this angle is 40 degrees. So the question is, what is the magnitude of their combined force? So I'm trying to find the magnitude of of their force that they're both impacting on the statue. In other words, we are trying to find, in order to find the magnitude of their combined force, we need to figure out what are their vector components, what are their x and y components, and then we can add those components together and find the magnitude of their combined force. So in order to find these, I'm going to go ahead and let me make Nancy blue. That way, just as I'm talking about the problem, we can kind of be focused on color here. I'm going to call this 120 magnitude vector n for Nancy. And so what we need to find is, if I drop down this horizontal here, I need to find n sub x and n sub y. I need the x and the y components for Nancy's force. Okay, in order to find, let's search for the x component first. In order to find her x components, if I take into account trig, SOHCAHTOA, I'm going to set up the cosine of 60 degrees is equal to adjacent over hypotenuse. So it's going to be the vector n sub x over the hypotenuse is 120. So if I multiply both sides by 120, then I get that vector for Nancy n sub x is equal to 120 times the cosine of 60, which is approximately, well, actually it's not approximately, it is 60, because cosine of 60 is 1/2, so 1/2 times 120 is 60. So that's the first number of Nancy's, that's her x component. And then we need to find her y component. So the y value is found by doing the sine of 60, which is equal to n sub y over 120. Again, if I multiply both sides by 120, I get vector n sub y is equal to 120 times the sine of 60. And then for the sake, I didn't tell you how to round in the problem, but for the sake of consistency, let's just go ahead and round to the nearest hundredth. That y component is going to be about 103.92. So that's the second component where her vector is for the y, 103.92. Okay, so we have Nancy's vector components. We need to do the same thing in order to get Harry's. So let's call this 180 Newton force vector H. And we need, if I drop down this vertical right here, we need Harry's x components of his force and his y components. So vector H sub x and vector H sub y. His angle is 40 degrees. So I'm going to repeat the exact same math that I did for Nancy, except I'm going to plug in Harry's numbers instead. So for the x component for him, it's going to be the cosine of his angle's 40 degrees is going to equal, I'm just changing my variable here to h for Harry. So vector H sub x over his force is 180. So when I solve for his vector x, I get h sub x is equal to 180 times cosine 40. That's what you type into your calculator right there. Again, making sure you're in degree mode. And then for that, you're going to get that's approximately 137.89. So that's his first component, 137.89. To get his y components, let me write that a little further this way. 137.89. To get his y component, we're going to do the same math, except the sine of 40 is equal to vector h sub y over 180. So then vector h sub y is equal to 180 times the sine of 40. And then when you plug that into your calculator, you're going to get that is approximately 115.7. So all of that work was basically breaking their two vectors up into right triangles, solving for their x and their y components. The question now is, what is the magnitude of their combined force? So we're literally going to combine them by addition. So if I add both of their x's together, well, let me just write their two forces actually. Okay, so this one, Nancy's is going to be 60, 103.92. That vector plus Harry's vector 137.89 comma 115.7. If I add their two forces together, then 60 plus 137.89 is going to be 197.89. And then 103.92 plus 115.7, their y's, are going to be 219.62. Still not the answer. The question is, what is the magnitude? Well, once you've added their forces, to find the magnitude, we're just going to take the square root of those components squared. So the square root of 197.89 squared plus 219.62 squared, which when you do that, you should get about the square root of 87,393.3965. And then rounding that to the nearest hundredth, we're going to get our magnitude answer of about 295.62. Always, always, always put your units. Notice their forces are being described in newtons, so their combined force should also be described in newtons.